This week we're learning about testing differences between means and the t-test. The agenda for today is we are going to talk about differences between two means and how we test them. We're going to talk about hypotheses, including the null hypothesis and the research hypothesis. Next, we're going to talk about levels of significance. And then lastly, we're going to dive into Excel a little bit. So one of the ways that we test hypotheses is through analyzing the differences in their means or their averages. So as a reminder, these are the 5 steps of the research process. This class is focused on step 4, which is analyzing results given our hypotheses. And so this is just one way that we could analyze our results. Again, one of the ways to analyze is by looking at the differences in the means. So let's look at an example. A researcher is interested in comparing 2 methods of increasing memory of nursing home residents. So they have method A and they have method B. They take the numbers that they have from their sample, these were different individuals, and they calculate a mean. So they have 2 means from group A and group B, and we're interested in seeing the differences between these 2 means. We see that A is greater than B, but is this difference statistically significant? This is what we are going to learn today. So think of it in a more basic way. Would you say someone who is 6'1" and someone who is 6'2" is different in height? Yes, it's different by an inch. But is it significant, this 1 inch that they're different? No. However, what I think is significant might be different than what you think is significant. So there's a way to actually test these differences to determine their statistical significance. So how do you do this? You do it through a t-test. And there's 2 types of t-tests. There's an independent t-test and a paired t-test, and we're going to go over both of those now. An independent t-test is used to determine whether there's a significant difference between the means of 2 separate or independent groups. So, as an example, this blue line here and this red line here. The blue line is a group of students who took the ACT in the morning. The red, this is a group of students who took the ACT in the afternoon. So our question for the t-test is there a statistically significant difference in the mean test scores of students who took the ACT in the morning and those who took it in the afternoon? So there's some rules when you are deciding to use a t-test. There needs to be 2 completely separate groups for the t-test, the independent group sample. So 2 completely separate groups, meaning some students who are in blue can't be in red, some students who are in red can't be in blue. It has to be 2 completely separate groups. The IVs must be categorical and the DV must be continuous. And so we learned about what that terminology was, the categorical and continuous variables or data, a lot earlier in this semester. Now, there's another type of t-test. This is the paired sample t-test. So its definition is, it is used to determine whether there is a significant difference between the means of the same group, but the means are taken at 2 different times. So as an example, same thing, blue and red groups. Blue is a group of students who took the ACT in the morning, and then here's where it changes. Red, it's the same group of students, but they took the ACT again in the afternoon. So the question would be, is there a statistically significant difference in the mean test scores of morning and afternoon results? So in terms of the rules, the one group, but it was tested twice. So this is the 2 absolutely separate groups. This is one group, but it's been tested twice. The IVs must be categorical, it needs to only have 1 DV, and it must be continuous. All right, we're moving on. Let's talk about hypotheses now. So there's a null hypothesis and there's a research hypothesis. So a lot of times when you just think of hypothesis in general, you're thinking about a research hypothesis. So why do we do research as social science researchers? Well, we're interested in seeing if there's a cause and effect relationship. A lot of time we're interested in cause and effect, but we're interested in whether there's a relationship in something. And generally, the point of us doing research is to show that there is a relationship. So the research hypothesis is that there is a statistically significant difference between the means of 2 groups. The null hypothesis is just saying the opposite. They're saying there's no statistically significant difference between the means of two groups. Now, what's another area that's really important with the research hypothesis and the null hypothesis is that the difference is true. And we're going to talk about that here in a second. So we don't want there to be a difference and it just be by chance, that it just kind of happened to happen. You got lucky. We want to show that there is a difference and that the difference was in fact true. So, research hypothesis has, with that last example that we just had in terms of the memory home, the nursing care, the research hypothesis will be there is a statistically significant difference between method A and method B. A lot of times it's shown on papers and articles, journal articles. You'll see this as the H1 hypothesis, so that's nothing to worry about, but I just kind of wanted to let you know as an FYI. You'll see it as the H1 hypothesis. So your research hypothesis can also be directional. It doesn't have to be. So instead of just saying that method A and method B will have statistically significant differences, you can also say whether one will be greater than or less than the other. So if you add direction to your hypothesis, this is called a one-tailed hypothesis. If you don't, it's called a two-tailed hypothesis. And we'll cover why it's called that here in a bit. All right, so for null hypothesis, this is, as a repeat, this is where there is not a statistically significant difference between method A and method B. And this, as an FYI, is shown on papers as the H0 hypothesis. So as researchers, again, we're hoping to see that there is a difference, so therefore we're hoping to reject the null. We are more interested in finding differences between groups. So if we reject the null, we therefore accept the research hypothesis. So we also assume that there is a real difference in the population as well, as long as it is true. So what makes something true? Well, remember from last class that the sample mean and the population mean are never the same. And why is that? Because of sampling error. And we discussed this earlier. We discussed it last class. So let's say you do find differences in your sample. Can we be sure that there would also be differences in the population? Well, that's what we want to check before we accept or reject the null hypothesis. We want to be sure that what we're saying and what we're seeing, if there's a difference, we want to be sure that there actually would be a difference in the population as well. So let's look at some things to look for. Some examples of true differences. So here we have, going back to that same example, we have a group that used method A and a group that used method B. Here we have a group that used method A and a group that used method B, but there's differences between these. So these ones have equal variance or equal variability, and these ones have high or unequal variability. And we'll talk about that just in a second. But as you can see, both of them have equal means. So the mean is 82, means are 77. The right has unequal variability. So let's take a look. So the 63 and 98, those are big differences in scores for those particular people. And the 56 and 91, those are also big differences. So if your sample has unequal or high variability, is unstable. So look at these. These are like all in the low 80s. These are all in the high 70s. If there's lots of big differences, big jumps, that should alert you saying that I might have sampling error here. So in that case, your samples are unstable and you would need to accept the null hypothesis, because while there could be statistically significant differences between these 82 and 77, your sample is just not stable and the scores are not reliable. So the lesson here is that just because there's a difference between two sample means does not signify that there's a true difference in population means. So try again with another more stable sample, because it looks like maybe you just got lucky in terms of seeing those means. On the left, these scores look stable. And as long as the t-test comes back as indicating that there's a statistically significant difference, we'll talk about this in a bit, you can accept the research hypothesis and reject the null. So this is being a responsible researcher checking for variability. So your turn. So here are some, let's go back to the ACT example of when we talked about the ACT being taken in the morning versus afternoon. So is there a difference in means, and is the difference truthful? So go ahead and do this for a second, and when you are ready, press play. Okay, here's the answer. So yes, 22.6 is in fact greater than 20. It may not be truthful though, because the afternoon sample has a lot of variability in those scores. Look, we have an ACT as low as 8, and then we have an ACT as high as 36. 36, I think, is the highest that you can get on the ACT. These ones look a little bit more stable. So because the afternoon scores have so much variability, we must try again with another more stable sample. Your turn again. When you're ready, press play. The answer, yes, 22.6 is less than 24.2, so there is a difference. And it seems like it's truthful too, because the sample scores in both morning and afternoon groups are stable and don't vary too much. So it looks kind of pretty good. All, you know, not bouncing around too crazy. So looks good. All right. So you might be asking, how much variability is too much variability? Because I was just saying, looks good, looks good. So that may have just seemed a little bit not too methodological for you. So you would have to compare your sample's means to the sampling distribution of the mean. We learned about this last class. This was the one where you took lots of different samples and you calculated those means, aka the mean of the means. A lot of times we don't have access to the mean of the means though, so we have to use something called standard error of the mean calculation instead. We also learned about this in last class, but for a reminder, here's that video if you want to watch it again. So that's how you can decide whether there's too much variability and in terms of ensuring that your samples have equal variance. Okay, so let's say that there is a difference in the means of the groups. Okay, so back here we saw that yes, there was a difference. Those are in fact different. Yes, there are differences, but we just had concerns about their variability. All right, so let's say that there are differences. How do we know whether those are statistically significant or not? So remember, here was my example of the height. Yes, there is a 1-inch difference here between someone who's 6'1" and 6'2", but is it significant? To me, no. However, I'm a tall person, so I don't think that 1-inch difference is a big deal. I know that short people tend to think that that's a really big deal. But there's a way to actually test whether these are statistically significant. And you do that through what's called level of significance, which we're going to talk about now. So the levels of significance, this is used to check whether our differences are statistically significant rather than a product of chance or luck. It's represented by a Greek letter alpha, the Greek letter A. It's just called the alpha. I'm not sure why it's called that. I Googled around for a little while, couldn't figure it out, so I'm sorry. But that's what it's called. It's called the alpha. Usually social researchers use a significance level of 0.05 to test significance. And if there's a difference between the samples is less than 0.05, we accept the research hypothesis and reject the null. If the difference between samples is greater than 0.05, we accept the null. So you might be super confused now. What does this mean? I'm going to talk about it now. So P stands for probability. So remember that everything we're talking about in this class now is about inferential statistics. The idea behind inferential statistics is that we can study a sample to make inferences about a population. Inferential statistics relies heavily on probability theory, the chances that something will happen. So thus, if you see a p-value, a p-level less than 0.05, there is a statistically significant difference. It also means that there is less than 5 out of 100 chances that the difference between samples is due to chance alone. And because of this, it shows that there's some kind of real effect going on to cause the samples to differ. The cause and effect relationship is indeed there and not just different by chance. So just a side note for those who need it, in terms of the alligator reminder, the greater than and less than signs, the alligator always wants to eat the larger number. So just remember that. Okay, so let's look at a visual of what I said right here. So this is our normal distribution, and I've talked a lot about how, this is the mean, and a lot of times scores gather around this mean. So this is, the mean is the central tendency number, and scores tend to gather around it. Now, if you get a score out in here, that's pretty significant. That's a big deal. And so it is, in fact, statistically significant if you get some scores out here in what's called the tails of a normal distribution. So 2.5 plus 2.5, what is that? 5%. So that is why we have a p-level of p is 0.05. So here, if our scores were out here, and there was statistically significant difference in the means, we would reject the null. All right, so a directional research hypothesis. Remember, a hypothesis is saying that there is a difference, and it's up to you. You can make it directional or non-directional. So if you did put directional relationship on it, though, then what would happen is that we would only be looking for differences on one half of the distribution. So we'd be putting all of our weight over here, and then if it was two-tailed and we think there's going to be a difference, but we're not sure in terms of direction, then we'd be looking on both sides. So that's just kind of an FYI. So even though you have something, we've chosen just as social science researchers at the 5% level, that that's where we want to test our statistical significance. That's a pretty liberal level. There's more stringent conditions where some researchers would want to just check at the 1% level, and I think I'll give you an example of that here in a little bit. But even though we're testing at the 0.05 level or 5% level, you could still make an error. And so you could say that there was a difference when there wasn't a difference. So there's two types of errors. There's type 1 error and type 2 error. Type 1 error is when we reject the null hypothesis and accept the research one when the null hypothesis was actually true. And then the type 2 error is when we accept the null hypothesis and reject the research one when the null hypothesis is false. So you want to avoid a type 1 or type 2 error, and these are some silly visuals of type 1 and type 2 errors. This is a silly one. This is more of one that would potentially realistically happen. This is a drug and whether it's effective or not. So these are just some visuals. Again, we try not to make an error. That's why we're pretty disciplined with keeping our alpha levels at the 5% level. But this would be at the 1% level right here. So it's even smaller areas where it could be statistically significant. So yeah, so some disciplines decide to have their alpha level at the 0.01 level. As social science researchers, we use the 0.05 level. It really just depends how high stakes your research is. I think I used an example of last class, like if you were doing something with medicine and you needed to know for sure it was going to work, you would want maybe at the 1% level, or the 0.01, same thing. So your turn. So act like we've run some t-tests. Here's what we get back as our p-values. Are they statistically significant? How would you write the p-value, the greater than or the less than sign? And then should we accept or reject the null? So let's do the first one together, 0.003. That is our p-value that we got back when we ran this t-test. So, is it statistically significant? Yes, it is, because it is less than 0.05. And that's how we would write it out. Should we accept or reject the null? We should reject it. So we therefore think that there is a difference, and so we are accepting our research hypothesis and we are rejecting the null. So go ahead and do the second one on your own. Answer this question, this question, this question. I'll give you maybe 15 seconds or so. The answer is no. The p is greater than 0.05. Should we accept or reject the null? We accept it. Last one. Number 3. Yes. And we reject the null. All right, so this leads us to our homework. So I'm a practical stats gal, so I wanted to make some homework of something you would actually do if you were doing a study. So we're going to watch this video on how to run a t-test in Excel, and then your homework is listed here, and we'll go over that. So let's go ahead and watch this video first, though.
So this is a quick video how to do a t-test in Excel. A t-test is when you have two conditions and you'd like to compare the differences between the conditions to see if it's significant. So my two conditions was just measuring reaction time to a stimulus in milliseconds. So I have my reaction times for condition A, my reaction times for condition B, and I'd like to see if there's a difference. Now these two means can either come from the same people, so for example, this could be reaction times in the morning, and this could be reaction times in the afternoon, from the same people, so each row represents one subject. Or it could be that I had separate subjects in each condition. So I tested these participants in the morning and a separate set of participants in the afternoon. Now, depending on what your design is, depends on what type of t-test you'd use. For the first type, when the means come from the same participants, it will be a related t-test, sometimes called a paired t-test. The way to do this in Excel is to first of all select a clear cell. So here I've got E6 highlighted. Then you hit on the keyboard equals, then write t-test, open brackets. Now you can see here that Excel is prompting me to enter array 1. What this means is it would like you to first select the means from the first condition. So here we have these means, so I just click and drag all of these. Once they are selected, I hit comma, and we'll see that we've moved on. Now Excel is asking you to highlight array 2. So this is just the means from the second condition. So now I highlight the second ones. Now I hit comma. Microsoft is now asking me to determine how many tails the test has. So if you predict that there will be a difference between these two conditions and you have a directional hypothesis, i.e. that condition A will be faster than condition B, for example, then this would be a one-tailed test because you predict the direction of the effect. If you're unclear, it's always best to do a two-tailed test. So this is when you predict that although there may be a difference, you're not sure which condition will be different, faster or slower than the other. So in my case, it's a one-tailed test. So I just click 1, hit comma again. Now it's asking me for type. Now this is where you distinguish in Excel whether the data comes from the same participants or from different participants. You have to enter a number here from 1 to 3, so 1, 2 or 3, depending on what your design is. So my design is a repeated measures design. Each participant took part in both conditions. This would be type 1. Type 2 is where the means come from different groups. Type 3 is also where they come from different groups. So what's the difference between type 2 and type 3? Well, type 2, if you were to enter a 2 here instead of a 1, you're telling Excel that the means come from different groups and that the variance associated with each group are the same, statistically the same. So you're saying that the two groups, the variance of the two groups have equal variance. If the variance of the two groups is unequal, you would do a type 3. If you're unsure whether there's equal variance between the two groups, you can test for this statistically. Perhaps cover this in a different video. But for simplicity, always best to assume that it's unequal variance, because that makes the test stricter. So you would choose type 3. But for our case, it's a repeated measures design, so we type 1. Now we close off the brackets and hit return. And now Excel has computed a value of 0.01672. What this is your probability. So this is your p-value. So in psychology we use criteria of p less than 0.05. So our value here is less than 0.05. So that says that the difference between these two conditions is significant at the 0.05 level. So just below it, we'll have a go at the other ones. So again, you just equals t-test, open your parentheses, select array 1, and then array 2. Let's do a one-tailed test again, and now do a independent t-test, so between subjects, but equal variance is assumed. Close brackets, hit return, and here we have a p-value of 0.00468, so it's highly significant also. So this is how to do a t-test in Excel. It's really simple, so have a play around with it and see how you get on.
With project.
And his British accent was a plus for us. So yeah. So your homework is to run 3 t-tests in Excel, and so I have this up on Canvas for you, and I have them here, here, and here. So the paired, the independent with equal variance, and the independent with unequal variance. Yeah, and then report the p-value for each one. Tell me whether there's a statistically significant difference or not for each one using greater than and less than signs and the alpha level of 0.05. And then tell me whether you would reject or the null or not. And then the second homework is for you to complete the following questions from your book, and then also write a research question and a hypothesis that could be answered utilizing a t-test and identify which type of t-test it is. And thank you. Please let me know if you have any questions. This is the part of stats where I really start to enjoy statistics because I see how useful it is, and it becomes more practical. So I hope that you like this lecture, and yes, if you have any questions, please let me know. Thank you.